Packronics are now stocking a product called the Arduino Alvik. I'm going to talk with you about what it can do out of the box. I'll also explore how you can code and program this device using MicroPython, and finally I'll discuss possible applications it has in the classroom. First of all, opening up the box and finding what's inside. When you first take Alvik out of the box, you'll see a little square-shaped robot, 2 drive wheels, a caster, some sensors looking down. There's also a sensor looking forward. On top we have the Arduino Nano, which is the brains of the whole thing. There are a couple of capacitive sensors on the top circuit board. On the rear of the circuit board there are 2 I2C ports for grove sensors. First of all, what can the Alvik do out of the box? At the rear of the Alvik here is a switch. I'll turn that on. Alvik does take a moment or two to boot up. Alvik has 3 programs loaded into it from the factory, and you can scroll through these programs by clicking on those little sensors, and you'll see the 2 RGB LEDs here will change color to indicate which program you have chosen. So there is green, blue and red. Let's start with green. I'll just click that tick there to make that program run. The robot has advanced forward until it's around 10 centimeters away from my hand. If I move my hand closer, you can see Alvik retreats. And if I move my hand away, you can see Alvik advances. The second mode is a line following mode, and this will detect a black line and follow it. I'll give an example of this now. Alvik is looking for the line. Now it's found it, and it's going to follow that line. Once it's finished following the line, it will then continue forwards in a straight line. Finally, in the last mode, red, you can actually store a program and have Alvik carry out that program. I'll do a forward, right, forward, right, forward, right, forward, right. Let's see what Alvik does. That's an overview of what Alvik can do straight out of the box. Those 3 built-in programs provide an opportunity to explore some very interesting robotic concepts without having to prepare any coding at all. In particular, what I find useful here is the sequential programming function, introducing students to the fundamentals of programming any robotic system. Students will have to consider every single step before the action is completed. You could use this in a classroom to very quickly deploy a session where students need to program Alvik to navigate an obstacle course. A great exercise in estimation. If you wanted to, you could add measurement to that, and the concatenation of a sequence of simple actions to have the students really begin to understand the steps required to have a robot traverse a specific obstacle course. Next, I'll explore with you how do we program Alvik and what is the programming environment like. Deploying the MicroPython IDE is quite easy. You can just run the IDE straight out of the unzipped folder. I'll demonstrate that here. I'm just extracting the Arduino lab, and I'll scroll down to the Arduino lab for MicroPython, double click, and away it goes. If you're working in a school where it's difficult to get software deployed quickly, this is a real advantage. When you first open Arduino Lab for MicroPython, if you've used the Arduino IDE before, you'll see that it looks fairly familiar. Now I'm just going to plug Alvik in to the computer using the supplied USB-C cable, and then I'll click this connect button here. You'll see now that Alvik is connected. There is a terminal window. You can see information coming back from Alvik. Down here we can see that there is 96% battery level. Once Alvik is connected, the file management system is quite simple to work with. So we click over here on the file manager, and once you've clicked over there on the file manager, you'll then see in your PC's Alvik home folder, whichever folder you declared that to be, any Python scripts that you might have created on the right, and you'll see the files which are being held on Alvik's internal memory on the left. If you want to move files between your PC's directory and the directory on Alvik, you can just highlight the file and click the relevant arrow, and that will be copied across. Creating a new MicroPython script for Alvik is simply a matter of clicking the plus sign here, creating a file name, then double-clicking that file to edit it. When a script has unsaved changes, there will be an asterisk next to the file name in the top tab there. Make sure you click save. I'm now going to go back to my file manager and transfer the script from the computer folder to Alvik. And you'll see that my distance sensor.py is now in the list of files stored on Alvik. To call that program, double click on main here, change the name from demo to distance sensor.py, save that, go back to the file manager, open up main.py and click run. We should see some live data coming in from the sensor. You can see here as the sensor moves forward and back from my hand, the data on the serial monitor is being altered to match. That's how the Arduino Lab allows you to see live data from Alvik. Another terrific feature of Arduino Lab is the ability to open and edit files straight from Alvik's memory. That's a little bit about how the Arduino Lab for MicroPython works. Next, I'll show you how you can access the courses in Arduino. If you head here to courses.arduino.cc, I already have an Arduino account, so I simply signed in to Arduino. You'll see here that there is a range of courses ready to go for Alvik. The Ready Set Code course here has everything that your students need to be able to get started coding Alvik straight out of the box. These courses can step you through from the absolute beginning to using the onboard LEDs, making Alvik move, and then there is a challenge at the end. The last thing I'd like to do is demonstrate how Alvik can connect to the Victorian curriculum from year 7 to 10. So here on the Victorian curriculum website, I'm scrolling down to the year level 7 and 8. It doesn't take much imagination to find links to the Victorian Digital Technologies curriculum. The handling of data and information obviously stands out, as Alvik has built-in sensors that you can poll data from. There is the Creating Digital Solutions, where students can develop algorithms to control the robot and to use data from the sensors. Mathematical connections can easily be linked to patterns and algebra, measurement and geometry from year 7 to 10, and statistics and probability there is plenty of room for mathematics discussion with Alvik. Finally, in the science curriculum, we have the physical sciences, where you can explore topics like forces and motion, using Alvik as a demonstration for how forces are acting on the robot as it moves. You can also link to the science inquiry skills, once again using Alvik sensors to investigate conditions in the environment. Perhaps you could use Alvik to navigate to an area which is not accessible by humans and collect data from that area. You could also discuss the transformation of energy, how electricity is transformed and used throughout Alvik's operation is also open for exploration. Alvik is available from Pacronics now. If you're looking for an innovative way to teach digital technologies, integrate science and mathematics, Alvik presents you with a huge range of opportunity to create unique and engaging learning experiences for your students. Take a look on the Pacronics website or give them a call to find out how Pacronics can help you create engaging opportunities for your students.